Hi everyone, my name is Ryker, and my research is in verifying the correctness of forward kinematics calculations for use in robot motion planning. With robot motion planning, our goal is to have robots move autonomously without creating collisions. This could be of use in a warehouse environment where we'd like robots to move packages around. This can be done in code and has been done before in a programming library called Amino. For robot motion planning, we need a way for robots to figure out where their arms are located in space. This can be done using forward kinematics, which uses the angle of the joints and the length of the links connecting the joints to figure out where the robot's arm is located. To do forward kinematics, we need a way to represent how objects can be moved in space. In 3 dimensions, objects can either rotate or translate, and we can represent that using a transformation matrix. The part with the sines and cosines represents the rotation, while the far right column represents the translation. Using this representation works for forward kinematics, but it can be pretty slow due to the large number of elements in a transformation matrix. To speed this process up, we can use quaternions to represent the rotation part. Quaternions use imaginary numbers to represent rotations. And to make them represent transformations, we can augment them with a translation vector, as shown below. Using a quaternion translation will give us the same result as a transformation matrix, but will be more computationally efficient due to the smaller number of elements in a quaternion translation. Now that we have our forward kinematics, we should test it before we use it in an actual robot to minimize the chance of anyone being hurt. To do this, we can use property-based testing, which checks that a given mathematical property is in place. An example property that we could test is that a unit quaternion has a magnitude of 1. To do this, we would just implement this equation in code. Now, to test our transformations, first it's helpful to test our conversions between transformations. Since quaternion translations and transformation matrices represent the same information, just in different ways, we can convert between the two using this equation. Now that we have that, if we take a random point and a random quaternion, first we can transform that point using that quaternion, and then transform that same point using an equivalent transformation matrix. These points should come out to be the same. If we do this across a whole range of different quaternions and different points, we can be absolutely certain that our forward kinematic calculations are correct. Doing this, I was able to prove that Amino's forward kinematic calculations are correct, which will minimize the chance of anyone being hurt by a robot once this is actually used in the real world. That's all I have. Thank you.